In this question, we're looking at the function y equals 2 times log e of x all divided by x. We're asked to find the x-intercepts, then we're asked to find an area. So firstly, to find the x-intercepts, we know for an x-intercept, the y value must be equal to 0. So that gives us 2 log e of x divided by x must equal 0. Multiply both sides by x, we get 2 log e of x equals 0. Dividing both sides by 2, log e of x is equal to 0, which means x is equal to e to the 0, and e to the 0 is 1. So our x-intercept is 1. We can also write this as a coordinate. The point that we have would be 1, 0. Part B of a question looks at the area bounded by a curve. The graph of that is shown here. We can see there is an x-intercept at 1, the one that we just calculated. We can see the curve shown in blue. We can see the x-terminal of 3. The area that we are trying to find is the area that I have just bounded in red. Going back to our working out, what you can see is we're going to have to work out a definite integral to find the area. That definite integral we can write as a equals from 1, the x-intercept we've just found, to 3, of our function. Our function is 2 log e of x, all divided by x, dx. Looking at this, we obviously don't have a straightforward antiderivative that we can do by formula, so what we're going to do is use substitution. You can see on the top line you have log e of x. The derivative of log e of x is 1 over x. So for our substitution, we're going to let u equal log e of x. That means du dx is equal to 1 over x. We also have the terminals to take into account. We have a lower terminal of x equals 1, which means that u will equal log e of 1, and log e of 1 is 0. We also have x is equal to 3, the upper terminal. U then will equal log e of 3. Log e of 3 isn't exact. We leave it as it is. Remember, in specialist maths, you use exact values unless told otherwise. So we can now rewrite our definite integral. The definite integral is going to be area equals the integral from. We had x equals 1. For x equals 1, we have 0. 2, x equals 3. X equals 3 gave us log e of 3 in terms of u. We now have 2 over x. So we've got 2 times x on the bottom line. So it's 1 over x. 1 over x is du dx times log e of x. Log e of x was u. Then we have our dx. tidying that up, what we get will be the 2 dx's in effect cancelling. We have 2u du. The integral is between 0 and log e of 3. And now we can do a straightforward antiderivative. When we antidifferentiate 2u with respect to u, what we get is u squared, and our terminals were 0 and log e of 3. We are now going to substitute in our values for the terminals. So I'm just going to move across here. Area is equal to u squared. U is log e of 3. So we've got log e of 3 squared minus, substituting 0, 0 squared. Okay. Log e of 3 all squared is our first bracket. Our second bracket is 0 squared. 0 squared is 0, so it has gone away. So my exact answer is going to be log e of 3 all squared square units, because we are looking at an area that, if you're interested, is approximately 1.207 square units. Returning back to our graph, the area that we've found is equal to log e of 3 all squared square units. You could have done this in a number of ways involving your calculator. So one way I have done it was I defined the function fx. Fx equals 2 times log e of x over x. Enter, done. I have then asked the calculator to solve when fx is equal to 0 to find the x-intercept. I've then asked the calculator to work out the definite integral by going the integral from 1 to 3 of fx dx, and that gives me the answer as we have in the graph above. Additionally, you could have done a decimal approximation of the answer. You can see that I have got the graph of the function. We had defined an fx on a calculator page. I have inserted a graph page, and for f1x I just typed in fx because I had already defined it, and it has drawn the graph for me. Then, using the integral function from the Analyze Graph menu, I have typed in the lower bound as 0, then the upper bound as 3, and pressed enter. And it has given me a decimal approximation. Notice it is approximation of 1.21, which is what we had to 2 decimal places when I wrote down the decimal approximation on the page before. And that was the reason why I did it, so you can see that the answers are the same.